Transport layer is a fourth layer of the OSI model. Transport layer delivers packet or a part of the message from one process to the another. Therefore, it is called process-to-process delivery. Next comes network layer. Network layer helps to deliver datagrams between two hosts. Therefore, it is called host-to-host delivery. Data link layer helps to deliver streams between nodes over a large layer. Therefore, it is called node-to-node delivery. Here, you are studying about transport layer. Here, the type of communication is done is process-to-process communication, and it is also called as end-to-end communication and port-to-port communication. This figure clearly explains how the delivery of message is done between data link layer and the network layer, also in transport layer. In transport layer, you are using different applications. Each application will have its own address that is called port address. The next position of transport layer. Here, here means the basic function of transport layer is the transport layer is to receive the services from the network layer, that is by using IP address, and to provide the services to the application layer where the applications are running on a computer. Here the transport layer lies between the network layer and the application layer. The basic function of congestion control is if there is a congestion in a network, then the transport layer uses different protocols, but with the help of different protocols, the congestion will be controlled. The next comes quality of services. Here, the quality of service of the transport layers is based on the packetization, connection control, addressing, and reliability. The next is what's the goals of transport layer? The main goals of transport layer is to provide efficiency, reliable, and cost-effective services to its users, normally processed in the application layer. To achieve this goal, the transport layer makes use of the services network layer. The types of services used in the network layer are services provided to the upper layer, next is service primitives, battery sockets. First comes service provided to the upper layer. The bottom four layers can be seen as the transport service provider, whereas the upper layers are the transport service users. To allow users to access the transport service, the transport layer must provide some operations to application programs, that is, transport service interface. Each transport service has its own interface. The transport service is similar to the network service, but there are also some important differences. The network service offered by real networks which can lose packets, so it's generally and reliable. Whereas the transport layer is reliable because it is connection oriented. The network services is used only by the transport entities. Few users write their own transport entities, and thus few users or programs ever see the network services. In contrast, many programs see the transport primitives. Therefore, transport services must be convenient and easy to use. Here in this figure shows how the communication is done from host 1 to the host 1 to the host 2. The upper layer is the application layer. Next is the transport layer, takes the services from the application layer and provides services to the network layer. Here in between that you are seeing the entity, transport entity. The transport entity used The transport entity is used to work as hardware and the software within a transport layer. Here, there is a communication from host 1 transport entity to the host 2 transport entity through the transport protocol. That protocol is called as Transport Protocol Data Unit. Here, this is the first layer where the end-to-end communication is going to done. By using the transport address, that is the port address, it is used to deliver the message to the network layer, and the network layer uses network address. By using that, it transfers to the host 2. This is about service provided to the upper layer. The next comes transport primitives. Here in this diagram, it shows the primitives and how the packet is sent and what is the meaning of that primitive. The primitives that application might call to transport from a simple connection-oriented service. Here, the client calls, connects, sends, receives, and disconnects. Server calls, listens, receives, sends, and disconnects. Here, the listen, first one is listen. The listen is used to executed by server. It means server is ready to accept connections. It blocks the process of server until connection request comes. Next is connect. It executes by client to request the connection. It sends connection request by using transport protocol data unit to server. If server is able to handle connection, then it sends connection accepted transport protocol data unit. Next is send. It executes to send data to the other end, that is at the receiver. Next, receiver. Receiver, whenever client or server is waiting for the data, it executes. That is, it blocks until a data packet arrives. After the arriving of the data packet at the receiver, the next is disconnect the connection. You have to disconnect the connection using execute disconnect. Two variants of disconnects are used. One is asymmetric, another one is symmetric. In asymmetric, either side issues disconnect when connection will be released. In symmetric, both the sides need to separate execute disconnection. The next shows the primitives for a simple transport service. In this, you can see the data along with the header. The first is the transport protocol data unit payload. That is the message in the transport layer. Along with this data, you are adding a header address. This complete data is passed to the network layer. The network layer receives the message from the transport layer. Along with that message, it has header. That is packet payload with packet header. Again, this address is sent to the data link layer. In data link layer, the message is in terms of frames. The data with frames, that is payload frame, is sent with the header frame. This is the nesting of TPDUs, packets, and the frames. The next is transport service primitives. This is a state diagram for a simple connection management scheme. In this, the solid line shows the client state sequence and the dashed line shows the server state sequence. Here, the italic are caused by packet arrivals. In this, the first is the ideal state. In this, if the receiver is in ideal state, it requests for the connection. In this, you are having two types of connection. One is TPDU receive, another one is connect primitive executed. The connect primitive executed is across client side, which establish active pending establishment, whereas in server side, the connection request data receives using passive establishment pending. Before the establishment of the connection, it is connected primitive executed across the server and across the client. It is connection accepted data received. After the establishment of the connection, it has to it has to disconnect the connection. Further, it sends disconnection request data received to the passive disconnection pending across the server, and across the client, it sends disconnect primitive executed to the active disconnect pending. After that, the disconnect primitive will be executed across the server and disconnect request data received across the client. After that, the two hosts will be idle. The next is Bartley socket. The socket was first released as part of the Bartley Unix 4.2 BSD software distribution in 1983. The transport layer, two processes communicate with each other via sockets. A socket acts as an endpoint of the communication path between the processes. Here, a machine provides a variety of services, and to differentiate between these services, each service is assigned with a unique port number. The IP address and port address put together defines a socket address. There should be end ports called a socket. The two end ports called a socket. In this table, it shows primitives and their meanings. The first primitive is the socket, which is used to create a new communication endpoint. Next is bint, which attaches a local address to the socket. Listen, announce willingness to accept connection, gives queue size. Accept, block the caller until the connection attempts receives. Connect, act, actively attempts to establish a connection. Send some data over the connection. Receive some data from the connection. Close, release the connection. This is about services by the transport layer. The next topic we will see is elements of transport protocol. Thank you.